To another session of Math Magic with Jen. We're going to finish up our unit on fractions with our last lecture. And this one, we're going to look at dividing fractions, but two particular types. And of course, we'll be illustrating them with Common Core methods. So the two types of division problems we're going to look at today are dividing a whole number by a fraction and then dividing a fraction by a whole number. Common Core uses tape diagrams to model both. I do like it for the first. I feel like there's some room for improvement in the second. So you're going to see me actually teach the dividing a fraction by a whole number differently than what's in the Common Core textbook. And you can decide if you like it or not. But yeah, I'll just show you my interpretation of it. So the first thing that we're going to do is we're going to look at dividing a whole number by a fraction. So to do this, we're going to look at 2 divided by a third. So here it is right here, 2 divided by a third. We're going to read it a little differently. So these are 2 whole units divided into thirds, okay? And reading it that way is going to kind of make the tape diagram strategy make sense, okay? So here's where we start, okay? So I've got a whole number divided by a fraction, and as I said, we have 2 divided by a third. I'll write it nice and big. So what we're going to do is we're going to start with a tape diagram. And the tape diagram is going to represent 2 whole things. Okay, so this represents 2 whole things. But what we want is we want to mark it off at every one. So to make it a little less confusing, they think, meaning the Common Core, thinks that it makes sense to have it floating above a number line, okay? So this is saying that this is 1 unit, this is 2 units. So these are our 2 objects, okay? Now, once we have our whole number taken care of, okay, so if this were 3 or 4 or 5, we would just extend this tape diagram, extend this number line, and cut it at every one. So we'll see one in just a second. Okay, now we want to talk about the second part of cutting it into thirds. Okay. So we've got our original picture. So here's our original picture with the floating tape diagram above a number line. And now we're going to come in and we're going to cut each of these into thirds, okay? In the Common Core textbook, you'll see them with dashed lines, and that's fine. You can even have it solid lines like I have over here. Now, I like to write inside that each of these is a third. So a third plus another third plus another third is 1 whole unit. Okay, so what we're asking our students to do is tell me how many thirds we have. And if we count all these little pieces, we have 6. So 2 divided by a third is going to give 6 pieces. So there are 6 thirds in 2 whole things. Okay. Now, what you can also do is you can have your students mark off and walk a third. So I'm walking a third, another third is 2 thirds, another third is 1, but that's also 3 thirds. Another third is 4 thirds, another third is 5 thirds, and one more third is 6 thirds, which is the same thing as the number 2. Now, you don't have to do all of this detailed number line underneath. It's just an option. I'm trying to give you lots of tools and options to decide what works for you and your student and your classroom. But I do like the fact that if I look at this too, it's 6 thirds, right? So 2 divided by third is 6, meaning there are 6 thirds in 2 whole things. Okay, so let's try one. So here I've got 4 divided by a half. And as you can see, I started off by having our number line down below, and I have a tape diagram that's been marked off into 4 whole pieces. So each one is 1, 2, 3, 4. Now, you may be looking at this going, Jen, how come your tape diagram is smaller? Why don't you have it spread out? You could. Okay, so if you want to have it longer, that's totally fine. We just need to make sure that we have students marking off every one, okay? Once we have our whole number taken care of, we're going to turn our attention to the fraction. So I'm asking my students, how many halves are in 4 whole things? So how many halves are in four whole things? So if I come up here, um, no, no. Now we can have them mark all of them, or, these are fifth graders. Maybe they're like, oh, I don't need to write them all. I get it. These are all halves. Okay, great. So if we ask our students to count them, they're going to get eight halves. So four divided by a half is eight. Practicing the number line one more time in case you want to use this method, we're going to walk out every half and just change the numerator. So one half, two halves, three halves, four halves, five halves, six halves, seven halves, eight halves. My favorite, I'll do it, right? If it means a difference in learning and having that aha moment, then do it. Do it. It's worth it. Okay. All right. Now, shall we do a completely different one for a second? What if I wanted to do 3 divided by, oh, am I gonna be sad I did this? 3 divided by 1/4. Okay, so I'm gonna do one more example just so you can see the original setup. So what we want to do is we want to have a tape diagram that is 3 units long. So we're going from 0 to 3. And then I'm going to mark it off at 1 and 2. All right, I want to set it up so you guys could see how that flows. I had it set up for you, but hey, if we have to start it from scratch, it's not the end of the world. Okay, what might be the end of the world though is we're going to cut them into 4. I don't know what I was thinking, but there we go. Okay, so here we go. Okay, so I've got 4 1/4 in 1 unit. So we're going to keep going. So we're going to have, let's see, we're going to end up with 12. Okay, so this would be the same thing as 12. And yes, you could sit here and mark it off, and we're going to get all the way down to 12/4. Okay. All right. Now, you might have been thinking, hey, Jen, so you were, after you did that first box, right, of cutting it into fourths, you went, oh, yeah, I've got 4 here. So then couldn't we just do, hey, I'm going to have 4. Hey, I'm going to have another 4 and another 4. Couldn't we just do a shortcut to 3 times 4? I mean, wouldn't that make sense if we just did a shortcut? Yeah. And in fact, let's talk about that because that shortcut is actually the algorithm, the standard algorithm for math. But how are we going to get students to discover it? Okay. So maybe one way they discover it might be like this, setting up and walking them through it. Or you could have more of an activity. So let's talk about an activity idea. Okay. So it could be fun. It could also be messy to have like a lab activity that illustrates this concept. So what I'm thinking about is instead of cutting, what if we did measuring, like, like cooking, like measuring cups. You can buy a set at the dollar store of, from a quarter cup to a full cup. But what if we had something that we could scoop and measure? Okay. Well, it's got to be something that's kind of easy to clean up and not too gross. So I was thinking maybe like some dried beans. At first I thought maybe cereal, but cereal, one, kids will eat. Two, if it falls on the floor and steps on it, there's going to be bits everywhere. So I felt like maybe like dried beans or rice, not cooked rice, but your standard bag of rice. Just something that they could, obviously scoop and stuff, but wouldn't get crushed and gross in the ground. I'm thinking. Okay. So let's go back for a second to our first problem of 2 divided by a third. So I imagine like having a table group, and you say, okay, we're gonna have 2 cups. So I need one of you guys to measure out 2 cups. So we have, let's go ahead and just say dried beans. Someone measures out 2 cups and they put it in a bowl. Okay, so that's person number 1. Person number 2 now is going to take the size of measuring cup that we need, and we need a third. So we're going to scoop out thirds. Okay, scoop out thirds and probably have a second bowl to put it in. Okay, so scoop out thirds. And then I need another person to count how many thirds we're doing. Okay. So what I'm hoping is that what happens is that we have, oh, okay. So if we have two whole cups and I need to measure out thirds from those two whole cups, we're going to get six. And maybe we have them walk through it. So first they did 2 cups of beans and they're going to scoop it now into half cups. 2 cups divided by a third. So scooping into thirds, scooping into fourths. So the hope is that we ask them, hey, do you notice a pattern? And what we're hoping is that they're going to notice that 2 divided by 1 over b is the same thing as 2 times b. And we could even put it b over 1 if you want to think about the algorithm we're going to work towards. Okay. And we can have them experiment like, hey, what do you think? So let's go back to that 3 divided by a fourth. Once they kind of have their hypothesis of what they think the pattern is, we could say, okay, write down your hypothesis. So maybe this is their hypothesis that they wrote down. We go, okay, so based on your hypothesis, what do you think this is going to equal? And they say, oh, I think it might equal 12. Okay, well, let's test it. And so we could have them test it. So it's this idea of kind of figuring out the pattern, testing it, and having hopefully the aha moment. And then we're going to generalize it. So how we generalize it is, and some of you might remember this. I've heard students say copy dot flip was one that I had a student say. I had keep change flip. That was another one I heard. Keep change flip. Okay. So what it's referring to is that the first one stays the same. So our number stays the same. So that's the keep. The change is we're going to change this division to a multiply. So that's a change. And then the flip is we're going to take that 1 over b and flip it upside down to b over 1. Okay. So keep change flip would be keep change flip. There we go. Okay. All right, now story problems. Yeah, we can do a story problem. I'm laughing because for me, story problems are awesome because it's the idea of critical thinking and problem solving, and that's all good. I'm laughing because I don't want students to use a tape diagram to solve this. And you're going to see why. It says a principal orders 8 sub sandwiches for a teacher's meeting. They cut the subs into thirds and put the mini subs on a serving tray. How many mini subs are on the tray? Okay, I don't want to cut this into 24 pieces. So what I could see happening is that if we did have a student start with this picture, so I'm not mad if they want to start with this picture, that's fine. But what I would say is let's just focus on the first one. If I do this first one and I cut it into thirds, hopefully we all agree that we're going to get 3 sandwiches, 3 mini subs out of 1. Well, what's going to happen if I have 8 of them, right? So 3, 3, 3. So that would be repeated addition or 3 times 8. Okay. Now, if we did have our keep change flip, what students could do is write down 8 divided by a third, and we get keep change flip. And I'm still getting there. If we do have a student that really does want to cut them and count, go for it. It's hopefully not going to take that much longer. If the difference of 60 seconds is going to make it them feel better about, that's fine by me. The point being, though, is that we're going to have 24 mini subs on the tray. Okay. Woohoo! We did the first type of division problem. Now we're going to switch gears to the second type. So that was a whole number divided by a fraction. Now we're doing fraction divided by a whole number. All right. So how I got to doing all this Common Core stuff is I teach at a community college. Okay. And Cuesta Community College. And the whole point of this course that I'm teaching is to help future teachers, know how to do this stuff. So for this is the resource notes, the resources for a fifth grade teacher. So if you're in fifth grade as a teacher, they give you a book of resources and they're like, great, here's how we're going to do this. So I look at this and I go, okay, what the heck did they do? So they have a tape diagram equal to 1, okay? They start off, so I'll write it over here. They start off by showing a half, and then they want to cut this into 4. And we just want to know what's the size of one of them. Okay. Well, see what size that is. So you have to actually cut both sides to match. And at this point in the problem, I'm like, okay, it works, but I'm not really liking it so much. So, I mean, this idea of extending the cut will work, but I thought, you know what? What if we use area models instead? We just did this. We just did multiplying fractions with area models. Why can't we do this, right? So here's why I like this. Number one is it's different. Like when I say different, I mean we just did a division problem with a tape diagram and a number line. And now you want me to do a division problem with just a tape diagram and not a number line, and it's equal to 1 and not equal to it just to me it felt like too similar, not different enough. So I wanted to go just totally different. So here's the deal. What I'm going to do is I'm going to do an area model, and area model is just a rectangular fraction model, right? A thicker picture. I've got my 1/2. And now what I'm going to do is I'm going to cut it into 4. So I just come over here and I cut it into 4. And I'm going to shade one of those things. Now, what you could also do is do the shading all the way across, and our double shades the answer, right? But to me, this now looks like an 8. What I also like it is that if you remember our little keep, change, flip, well, if we're going to do keep, change, flip, it would be keep, change, and then flip. So this is also matching our picture we did just a little while ago of 1/2 of 1/4 or 1/4 of a half. Same deal. To me, it's like, woohoo, it makes sense. It should go together. Okay, I hope it makes sense for you that it should go together. So for the first type of division problem, if you have a whole number divided by a fraction, we'll use tape diagrams with number lines. Okay. For a fraction divided by a whole number, so the fraction is first divided by a whole number, I'm going to use area models. And here we go. Okay. So this one says find 1/3 divided by 3. So I'm going to come over here and I'm going to graph 1. So we start by graphing this fraction, and yes, I'm going to label it. There it is. It's 1/3. Now I want to cut this into 3. Okay, I'm going to be ridiculous. I'm going to overslice just so that everyone can see that I'm cutting this into 3. And then what I'm interested in is shading one of them. Okay, so this right here is my answer. That is 1 out of 9. So 1/3 divided by 3 is the same thing as 1/9. It's also 1/3 times 1/3 is 1/9. So it's meshing those two together. Whew. Okay. All right, let's do another one. Find 1/4 divided by 2. So the very first thing I'm going to do is I'm going to graph 1/4. Now, 1/4, we can shade any one of the 4. So you could do the first, second, third, fourth. I don't care which one you shade, but we just need to do one of them. I am going to label it. You can decide if you want your students to label it or not, but I'm just going to go ahead and label it so we all agree that's 1/4. And now I want to cut this into 2. So cutting it into 2 means I'm going to come across and cut it into 2. Okay, now, if you don't want to do the double shade, that's fine by me. What you could do instead is just shade one of these guys. So any one of these two. Okay. or shade all the way across. But this is our answer. Our answer is 1 out of 8. So 1/4 divided by 2 is the same thing as 1/8, and that's also the same thing as 1/4 times a half. We're still going to get that same picture. Okay. We do a story problem. Of course. Of course, sure. So this one says Sandy is a music teacher that spends half of her workday giving piano lessons. Awesome. So I guess this box is gonna represent her workday. Let's keep reading. If she has 3 piano students a day, then what fraction of her workday is spent with each student? Okay, so this whole sounds weird that this looks like your workday, but this is our workday. Okay, and we're going to cut it in half, and this is going to represent her piano students. I don't know what she does with the other half. Maybe clarinet. So there we go. There's her piano for half of the day. Now she's got 3 students that are gonna share that time. So we are going to cut this into 3. So we have a half divided by 3. So we want to fair share this into 3. So let's go. So fair share into 3. And one of these represents 1 student. So this is 1 student. 1 piano student. This is also 1 piano student. This is also, so just highlighting one of them is showing what fraction of her day is 1 student. Okay, so that would be 1 out of 6. So what fraction of her workday is spent with each student? 1/6 of her workday is spent with each piano student. Woohoo! Call it a day. You may be wondering, hey, you didn't talk about a fraction divided by a fraction. I know. So for the course that I teach, we're just told to do division by fractions, and we get to kind of choose how much or how little we do. So I just focused on these 2 types. The reason being that I figured that once you've established this, once you've established keep, change, flip, then if you got to things that look like this, you would just do keep, change, flip. So keep, change, flip. And then you would just multiply straight across. We don't have to worry about it for our class, but I just want to let those that are watching this thinking about what's the next step for fraction times a fraction. Honestly, I would probably just go straight to the algorithm and have them just crank out answers that way. Okay. All right. I hope you enjoyed today's lesson. We did division. We finished off fractions. Woohoo! Okay. My next unit, unit 4, will be coming up pretty soon, and it's on sort of a hodgepodge of 6th grade. We're going to be doing some ratios, rates, integers, all sorts of stuff. But until then, keep working on stuff. I hope fractions and math is less scary now, and have an awesome rest of your day and keep working hard. So until next time, have a good one. Bye-bye.